Hey, what's up? It's Derek Martin from CodeOpinion.com. So the industry moved from a monolith to microservices, and now we're well on our way back to a modular monolith. Was it worth it? Did we learn anything? Well, that's a conversation William Brander and I had. He's from Particular Software. If you're in the .NET space, they are the makers of NServiceBus, and that's the kind of conversation we had about around these topics. If at any point during this conversation you have your own thoughts, opinions, make sure to join the conversation by leaving a comment. Here we go. All right, so one of the things I wanted to bring up was kind of this swing that if you're old like me, I'm not saying you,
And me,
um, where we
chronologically
kind of
gifted.
where we see this kind of swing. Everybody notices it if you've been around long enough. I think it kind of seemingly happens in that like the 7 year range. I don't know why. That's just the number I come up with, where we kind of see like the tides turn a little bit, kind of swings back to where we kind of were somewhat in a
Yes.
slightly different way. I think the biggest one that we can talk about right now is where we went from quote unquote monolith. And then we had this hard swing in, I don't know what year it would have been, probably like early, like 2010, so 2011, somewhere around there, maybe, to microservices, whatever that means. And then now, I guess even a little bit, maybe 10 years later, somewhere around there, we're to being said, okay, microservices are bad or they're very difficult. There are all these downsides, which we can get into. Well, maybe
Yep.
I think that's inaccurate. Maybe the implementation details are kind of there. But now we're into, hey, let's go back to a modular monolith. Obviously, I'm assuming you've noticed this, I guess, as well. Where do you think it stems from?
Where does it stem from? That's a very good question. I don't I don't know where it stems from. I think there's a lot of frustration with engineers as we try and solve these problems. We come up with ways that seem like they're going to be good ways to solve the problems, but then very quickly we hit the limitations of them, and we actually no, that's not even true. It's not the limitations, and then we realize that we're not solving the right problems with them. So the let's see, when I started development, it was, I think, as SOA was just about kicking off. It was just becoming a thing. There were people starting to talk about it, and that was going to allow you to reuse all of your code and all of the systems internally, and you could just drag and drop new workflows, and it'd be great. Um, and very quickly, people realized that SOA wasn't actually solving any of the reuse problems, because the code that we were trying to reuse wasn't intended to be reusable. Um, and I think a very similar pattern plays out across all of the kind of swings in technology that we have, where we've got these promises of this will solve all of the problems and it'll be the best development experience you've ever had. But it's not solving any of the problems that are actually problems or meaningful problems. I mean, if you look at microservices, the size of services was never a problem. Why did we want to make them smaller? And monoliths, which is sort of like a swear word these days, monoliths aren't bad. Some of the best systems that I've ever worked on are monoliths. Um, but then people abandoned monoliths because they wanted to do microservices, because they wanted to solve various problems. And now we've realized that microservices haven't solved anything. And in fact, they make things a lot more complicated a lot of the time. So we as an industry are now pivoting to modular monoliths, which again, I don't know if we know what problems is going to solve. So we'll see in 7 years' time what the next iteration is.
Yeah,
Micro monolith or something.
yeah, it's gonna be something of that nature. But having like, I'm with you on everything there. It's the thing that kind of throws me off a little bit is once we kind of get into this full wave of, say it was microservices, for example, and then like you said, it's monolith almost became a swear word. It's I genuinely curious if you were at a conference, which you probably may have done this. So it'd be awesome if you talk to people that, or even poll people. It's like, what are the physically like? What do they actually think the differences are? Because where I think it got way out of or misunderstood. One on the sizing was a kind of an issue, but what did a service like? What if you ask somebody what is a service? And then you ask everybody else, what is a service? Do you think you could actually even get a decent definition of what a service is?
This is fantastic because I remember a talk by Don Box, probably early or mid 2000s, where he was talking about soap, and he spent a good 10 minutes discussing the differences between a service and an API. And honestly, like looking back at that video with a lens of almost 20 years of progress, I still don't know.
Yeah.
I do know that I deal with a lot of people, and the very first thing they say to me when they describe their system design is that they say, well, it's a microservices design. And probably about 80% of the time, that means that they've got controllers exposed via HTTP or REST. And for them, that means microservice because it's just little REST endpoints that you can expose and scale up or down. For me, that doesn't mean microservices, but that's one of the problems with the way we name things like microservices. It doesn't tell you anything about what it is. All you know is it's micro compared to macro, perhaps, and it performs a service of some kind, whatever that means. So if you stick a HTTP endpoint in front of your database, suddenly you've got a database service, right?
For the most part, I would say, although people wouldn't call it that, that's generally what's happening. But I think if I were to guess kind of the standard answer people would give, or if you really kind of dug into it, is really what you're alluding to, which is I'm really concerned, well, not concerned, but thinking primarily about a physical boundary of something independently deployable that I'm going to expose over HTTP to for other consumers, and that's how they're going to interact with this service.
Yeah.
I think that would be kind of how I would think most people would think of a microservice, is thinking about more of the physical deployable nature of it rather than what it actually does.
Yeah, I think that's a good heuristic. I think a lot of people do feel that way or do think that way, um, because it's easy to reason about the physical deployment of something, right? You can think, well, oh, I've got this web endpoint, and oh, if I get Amazon level traffic or Google level traffic, I can just scale this endpoint out X amount of times in different physical locations. That's a perfect microservice. So I agree. I think that's a good first impression of what people think when they start trying to implement microservices.
So I think this somewhat relates is when I go back to kind of the original question of like where certain things stem from. In ways, what I'm about to say is I think it's always been there, is a really data centric view of everything, or like the tendency to be very data centric about kind of everything. I'll give you the
Yeah.
example of if you, but it kind of wasn't always this way. So this is the example. I was just working on something related to this, which is if you think about like a late or late 90s, early 2000s, server side rendered, whatever tooling you were using for that, and you were generating some web application that was primarily, you know what I mean, you had just your browser, really no JavaScript, right?
Yeah.
Where you server side rendered, say, some table for records in a database. You clicked on the edit link, you went to some form that was a form that posted, and you just kind of go into that get post cycle, that pattern. When we were doing that, although it was kind of data centric, and then you really could be just generating forms on top of a UI, or like a UI on top of your database, there was still more to it than that, though, because your page that you were rendering just necessarily wasn't a single row. It was a composition of a bunch of stuff. You still had like navigation that was still always there. If you were looking at like an order, for example, you may have a link in it that links to the customer, or you kind of had that customer information there. There was a lot more composition.
Mm.
And then somewhere along the way, when we started going primarily more to single page or returning JSON as your representation, all of that went out the window, where it just became, oh, here's my order. no customer information, no way to navigate it, no way I had at all how to deal with it. And it's very, very data centric. Where I'm going with all this is I feel like services became that same thing where it's like we have still thinking about really large schemas, but then saying, okay, like this particular table has a service and
Yeah.
it's driven around CRUD. And then
Yes.
that's where you kind of end up where all these, especially over HTTP, we're just making HTTP calls everywhere from service to service, essentially what would be a database call.
Yeah. Uh, what it used to be called forms over databases. I've recently heard the term DDD over databases, which
Yeah.
I think talks about very shallow entities, very shallow aggregate roots, um, and that leads to having your services essentially being an entity. So give me all
Mm,
of the order information. Well, what are you doing with that order information? That's not the question that's asked. So we're dealing with an entity. So obviously our service boundaries must be around the order, right? That makes sense. Um, and ironically, the whole microservice part probably should have been better applied there. We should have made the service boundary smaller, because if the service boundary is at an order level, remember your service boundary should be like a DDD aggregate root. It should be a consistency boundary. Anything inside of that service boundary should be consistent. And if you've got an order as your service boundary and a bunch of other things are happening to orders within the processing of fulfilling an order, it's highly likely that you're not going to have a consistent boundary, or you're not going to have consistency around the entire order service boundary. But if the service boundary was place order within the bounded context of orders as a concept, the service boundary there is smaller, which means that you're not dealing with the entity anymore, but you've got a higher likelihood chance of having um, consistency around your service boundary, which falls more in line with the DDD aggregate root, I believe.
well, that's interesting too, because I think about, okay, if you're concerned, I'm generally curious of, because it's kind of a comment that comes up a lot is, okay, if you're concerned about consistency, but you have multiple different services that are independently deployed, that's usually the, well, I used to just be, and I have different databases. It's like I used to just be able to have a transaction,
Yep.
and now what? And I think that is kind of the somewhat of a problem, or some kind of the pitfalls that people fall into. But that's not necessarily because you have them in it. Well, it is because you have them separately deployed, um, and they're whatever, not using necessarily the same database. But again, it goes back to what you're saying, where was what was the thought into put in what goes where?
Yeah. It's it can't just be a case of, well, these attributes are all related to orders, therefore they all belong to the order service. It cannot be that, because there's such a high likelihood that you're going to have to access data or get information from something that's not within the order entity to be able to make a decision about it. Something silly like users in this role are allowed to place orders up to a value of $1,000. If they're trying to place an order that's above $1,000, they need to get approval from someone else. That's a business rule, right? But if you've got the user roles in an authorization service or something like that, and the order information in the order service, as soon as you try and place an order in the order service needs to go to the authorization service and say, hey, what role is this person in? Now, from an implementation perspective, there's many ways you can solve that problem without actually having to have a dedicated authorization service. But a lot of people, unfortunately, do end up having things like an authorization service, because all of the examples we see about microservices are these very anemic entity type models. There's very few good examples of service boundaries that are concise. What is the term? It's as small as possible and as big as needed. A lot of the examples we see are just attribute or entity based service boundaries, and it's very difficult to learn correctly from those.
I think for me, I've said this a bunch of videos, it's so difficult to give examples that are, I don't know, complex isn't maybe the right word, but detailed enough, large enough, and nuanced enough to really do some explanations justice sometimes. So they
Yes.
become very simplistic examples that you then have to really think about and really kind of fill in the blanks a little bit, because there's like a lot of patterns and things or ideas that are used that like don't necessarily apply well to the examples given. So that's always usually a challenge.
Yeah. It's very much one of those things where if you when you work on a system that's been done well, it it opens your eyes, and it
Yeah.
like a light switch goes on. You think, wow, how did I ever think that it was okay to do things in the previous way? But coming up with an example that you can put on a blog post or talk about in a 60-minute conference talk or on a YouTube talk, it's nearly impossible because you can't get, as you said, as nuanced as you need to. Like the typical examples you see are booking a slot in a classroom for university students, um, or reserving a hotel room where there's physical constraints and there's very clear boundary transitions between, well, the classroom is full but the student has booked, so who needs to be consistent around this? But it's those are I feel like they're focused too much on uh, the example that you've been given rather than exploring what the example could have been. So I'm trying to think how to explain this. Um, if you get told build a system that allows you to select or book classes within a university course, that's fine. But immediately, like you, all of the examples start with, well, what we've got is we've got a course, and then we've got a student, and then we've got classrooms, and then immediately you're already dealing with the entities involved, and it's usually used as a way to show where things break down, such as, well, this course is full, but a student managed to register before the consistency was updated there. I think what might be nice is if we could see the smaller service boundaries around reserve a seat in a class or something like that. But I haven't come across examples that focus on those aspects of it.
Yeah, it's kind of difficult. And then as somebody that posts stuff, I always get the comment of, well, you could just string a bunch of things together that turn into kind of like a very long form of it,
Yeah.
which is true. However, that still requires somebody to go through, because like the examples that I would love to use, like I just, yeah, they require a little bit of domain knowledge that you have to explain, even kind of, it's kind of superficial, but even at a level, because there isn't necessarily a correct solution. There's just there's different ways that you can take things. It depends on ultimately where you want to land.
Yeah.
So, and then in some of the spaces I've been, it's just hard to give those examples because it would require me to go on some tirade of 3 hours talking about something. But I want to get back to, I mean, because you're making me think of it when we're talking about boundaries and kind of the entity centric view of them, and kind of us swinging back to more of a monolith where you're in process and we just took out that network boundary, that physical boundary, because it was difficult. But did you really solve anything by now being in process? Right. So we went from, hey, this is very difficult. I can't have some transaction because I need to do this and this. And I'm separated by 2 physical instances and 2 different databases. So all of a sudden, I'm going to go back to a monolith, or sorry, modular monolith now. But I'm really just trying to do the same thing, but in process now, and it allows me to do it. But it's like we didn't really get anywhere.
The coupling is still there. So a lot of the problems that we talk about with microservices are symptoms of um, coupling problems, I think. Well, I've got a theory anyway. And by shifting to a monolith, we hide a lot of the other symptoms of coupling, but we still got the same coupling concerns in the code. We've just now, as you said, removed the network call. Perhaps we've restructured a few things. We've made it a bit easier to come up with reports or custom reports for our customers. Um, but there's everything is a trade-off. You make a decision on how you're going to implement something, whether it's going to be microservice or modular monolith or a monolith also or whatever it is. You're trading some set of uh, attributes for another set of attributes. And the modular monolith might be easier for you and your team to grok and to work with, but it's not necessarily inherently better or worse than a monolith or microservices or any of the other ways of implementing software. Because ultimately, the hard problem in software isn't how you deploy things; it's how you tease apart the the coupling of all the pieces. So if I change this, what else has to change to be able to reflect that change? If you've got a monolith where if you deploy a change, you only change it in one place, that's just as easy as if you've got the world's best microservice system and you deploy a new bit of functionality. There's no difference there. You've solved the coupling problem in two different ways.
Yeah, I think I yell about it a lot on almost everything I think I've posted on this channel. If you get to the root of it, generally, it comes down to coupling.
Yeah.
I feel like everything ultimately can kind of get rooted there for the most part. Um, and I think that's kind of a big challenge is, like you said, it's feeling like, oh, all of a sudden I'm making this HTTP call instead of an inline call, and that coupling magically disappeared, but it did not at all. And then so it's kind of that understanding of how you're coupling, the degree of coupling that you have, where, but then there's also kind of this notion of, okay, well, I'm using EDA or I'm using events and a broker or a queue. And then I'm also now that just magically made the coupling go away. It didn't. It just makes you feel like it did because you're like, oh, but you know what I mean? So I went from an in-process call. Now I'm doing a remote call. Now we remove that. Now I'm just I'm using messaging. And so I don't have that temporal aspect, but so you think it's just magically I'm not as coupled anymore. It's like you are, it's just in a different way,
Yep.
basically.
You're trading
So
one set of frustration for another set of frustration.
100%, yeah. So I think for me, like the coupling part of it, I always say that for me, coupling and cohesion are kind of like the push a little bit and pull against each other. Because you want a lot of times people will want cohesion for one reason, but it's kind of like more, I don't want to say in thinking about it the wrong way, but how stuff is being put together or organized um, at the cost of coupling and increasing it. But I think just generally, just I don't know. I mean, for me myself, as in the last 20 something years, I feel like it's not talked about. Like I watch videos all the time and I point out videos or if I do reviews on things where it's never even mentioned. Like coupling is like a word that's just not talked about, but yet I feel is like such a strong impact on pretty much every decision people are making, whether they're realizing it or not.
Yeah. Every choice you make is going to have an impact on where the coupling is and how much the coupling is going to impact you in the future. So when you make a technology choice and you say, well, we're going to do a modular monolith. Look at us go. We can now deploy things very easily. We've got our time from push to production is 2 minutes, 30 seconds, whatever it is. And then 5 years down the line, the requirements have shifted sufficiently that the the coupling that you chose, that your system originally worked really well for, is now starting to get in the way. That it's not a case of this is the one best architecture that's going to be architecture. I hate that word. This is the one
I
best way
know
to
I was.
design your system so that you will never have coupling ever again. It's requirements change. Systems aren't static. They're living creatures that evolve over time with the requirements that change. Um, which reminds me, and I probably should have mentioned this earlier, one of the areas where microservices are absolutely terrible are where you don't know the requirements of the system up front. When they're changing frequently, microservices are, and I think I can say this quite safely without even needing to caveat it with unless, but microservices are really bad in situations where the requirements of the system change frequently. If you've got a stable set of requirements, microservices can be a great way to implement the system. But if the requirements are constantly changing, you're in for a world of pain.
Yeah, I think in terms of like when you're mentioning like evolvability, I guess if that's a word. In
It is now. We've claimed it.
Yeah, it's just I mean, like you said, it's changing over time. The one thing I think the jump to is for microservices has been like just kind of that independent deployability, but also like you mentioned at the very beginning, like for scale. Um, but I think where monoliths got a bad rap there is there's just so many options to even scale a monolith um, that unless you actually need that independent scale of that particular unit that you want to deploy independently, um, there's just so many options too. Like I'm not suggesting, hey, jump to a monolith. I'm just saying like if you were writing off a monolith because of scale concerns, um, there's just so many options. Um, I have a bunch of posts related to just different ways of dealing with it. Obviously, scaling out, but it's not even just scaling out. It's you can be scaling out just parts of it into kind of different groups, if you will, that get more traffic. So you can have those resources be different than another part of your app. It's still the same underlying process, executable running, built on the same code base. It's just that you may have different resources needed for different parts of it. Same thing goes with I was mentioning like moving to messaging, or even right from the get go, parts that you can move work asynchronously to what I mean have that load separately where you have still the exact same code base running separately, but instead of it being the entry point being say HTTP, it's listening to a queue.
Yeah.
It's still this underlying same code base. You still have that benefit of all that being there. I just think there's so many ways that you can deal with it that the jump to, oh, well, I need to scale all these things independently. It's kind of like, do you?
I do kind of wonder if there was contextually a different compute environment when microservices started becoming a fad. Like nowadays, we can spin up a new instance on EC2 and scale it up and down and just drag and drop things. But in the 2010s up until probably mid 2010s, like 2015 ish,
Yeah.
somewhere around about there, it was probably still a lot of people were on-prem data centers with running
Oh, yeah.
VMware.
Yeah.
Um, and I kind of wonder if maybe the desire to move away from monoliths wasn't somehow related to the infrastructure that we had to work with.
Yeah. I have a tough time thinking about what it was to think about how I think about it now. Be like, oh, yeah, it seems like totally feasible now, what I'm kind of suggesting, which is, but then if it was, I mean, however many years ago, like say 2011, 2012, that might have been more of a challenge.
Yeah, yeah, exactly.
Hence things changing. Yeah.
Every 7 years, a new way of hosting technology comes out. There we go.
Yeah.
That's
I
why
don't
we
know.
got the shift.
Yeah, I just totally made up the 7. I don't know why the 7 years, but it kind of feels that way, a little bit. I don't know why. It feels like and I don't mean to be like a old man yelling at cloud type thing, which I kinda am here sounding like that, but it's I feel like stuff changes a little bit. It just changes it enough where it's kind of, like, different, and there is obviously progress, I think, that happens, but it also has a lot of like you can follow it online. Like people, anything that something comes out that's new, it's like, well, that existed, you know what I mean, 8 years ago, and this has had the problems with it, and so on, this will too. But I think it does. It's kind of like not learning from the past a little bit, but things do change a little bit. The time, like everything else, kind of changes with it. That kind of makes it a little bit more appealing, or because of the pain that we just went through.
Yeah.
So that's why I'm really curious about, okay, this push to a modern modular monolith, like where is that going? Is it just a pure reaction based off of the super correction of one way and not understanding kind of the differences between a physical boundary and a logical boundary? Is that all we're really talking about? Like, is that really what happened? Is like, hey, they're not the same thing. So, and until we figure that out, we'll just keep going back and forth.
I there are so few people talking about the difference between a physical and a logical boundary that I think you might be onto something. Um, Even when you I'm sure you've seen in the comments on your videos when you talk about the fact that just because you deploy something physically in two different places doesn't make it the same logical, or doesn't make it different logically. And if you take the same logical thing and split that physically into two separate locations, it doesn't make it two logically different things. I'm sure you've seen in some of your YouTube comments that people just get upset about that.
Because they've been a one-to-one
Yeah.
always. I don't know why that is. And maybe it's easier to reason about.
Oh, it definitely is. Because then when you're drawing your architecture diagrams, you've got your one little square here, your one little square there, and the arrow between them, and it's great. You don't have to worry about the other 3+1 views, just
Yeah.
just the one.
Yeah, I often wonder if that's kind of where this stems from. There was a, I don't know if you read or knew much about Google Service Weaver that came out probably a year or so ago, maybe more than that,
No, I
if you're
don't.
familiar. So there was a paper that came out with it too. I'll have a link in the description so people can go read it. What I'm about to talk about here is that it was, what kind of threw me off is that the paper, um, right at the first paragraph, called out there being like the problem, some of the problems that are arising with microservices are not making the distinction between logical and physical. So
Okay.
when I was reading this, I was like, wow, like somebody's actually, because you said like it's not kind of really talked about enough. So I was like, wow, this is interesting. But then I continued reading it, and then what ultimately Service Weaver does is it really it's so it becomes, as you kind of in your development mode, you have to treat every, I don't know what they call them, modules, like calls between modules. You have to treat it as a network call. It forces you to treat it like a network call, even though if you deploy them together, it actually will turn it into a local call, like in memory.
Okay.
But you have to treat them physical. But I'm like, so I don't know how this helps anything.
Yeah,
So
you've
you just,
still by having calling between different components, you still got that coupling between the different components. So
yeah,
regardless of whether you've made it a network call or a local call, the coupling is still there.
yeah. And but it just forced you to deal with it, make it the assumption that it's a network call, like, because you have to deal with timeouts. It forces you down that road. It's like,
Mm.
okay, great that it's like forcing you to do the things maybe that you wouldn't necessarily do, and it made it transparent that it's a local call, but like you just still have that coupling that you can just willy nilly without much thought say, okay, I want to, I mean, have this module, and never mind where they're deployed, and I'm gonna have some coupling between them, whatever that is, and I don't know what it was solving. Like it's kind of, to me, the way I described it was kind of like a band-aid.
Yeah, it sounds a little bit like WCF and COM and DCOM.
That's what a lot of the comments were, I think.
Just
But
we'll make it a code call, but it could be a remote call,
yeah,
or it could be local. We'll find that at runtime.
I get, so I mean, what do you think the reason is why there's not this distinction? Is it just because it's very hard to conceptualize like what a local or sorry, what a logical boundary is when you're thinking about things as, um, well, like we said, it's just easier to reason about thinking, okay, I have this source code that I'm compiling or whatever the case may be, turning it into some deployable unit, right? Like it's the all be like that logical boundary is some development view, some repo or something that turns into some deployed artifact. And they're just all a one to one to one. And it's pretty easy to think about.
Yeah.
But if you start mixing and matching all of these, I think it's harder to think about them all in tandem or separately.
I think so from what I see with the people that I interact with, there's two ways that they can view the difference between logical and physical deployments. So the one is you've got one logical bit of code and you deploy it to 5 different places physically, but it's the same code that's deployed in all 5 different places. That people seem okay with because that's scaling out. It's just I've copied this
Sure,
code
yeah.
and stuck it somewhere else. What people don't seem to have as easy a time grasping is you've got one logical bit of code and one portion of that logical bit of code gets deployed in this assembly and another portion of this logical bit of code gets deployed in this assembly over here. And one bit of this logical code over here is controls whatever database it needs to. But now you've got two different bits of functionality deployed in two physically separate locations. It's still logically within that one service boundary because the coupling is internal to that boundary. The consistency is within that boundary, even though it is a remote call. And that's sort of the logical to physical deployment mismatch that I think a lot of people struggle with, because it doesn't make sense to have a different bit of functionality from the same logical endpoint over here and over here. If the functionality is different, they must be logically different, right? And they are, but that's code logic, not service boundary logic.
Yeah.
Um, within a service boundary, if you've got a bit of code that's deployed physically over here, for instance, something that allows I don't know, a UI screen to query the orders from an order database somewhere. And then you've got a separate service that listens to a queue that picks up messages that allows you to place a new order. Those are still within the same bounded context of the orders. And I've just made the same mistake that we spoke about earlier, talking about entities instead of.
Yeah.
But we'll go with it for now. But logically, that's still within the same bounded context. Just because you've deployed different bits in different places in different ways doesn't mean that it's not. It's again, it's one of those things I think where when you see it work in a system where it's been implemented well, you wow, why are we doing this the other way around? And to preempt it, there is still coupling in those examples, but the coupling is internal to the bounded context. So you can make whatever changes you want within the bounded context. As long as you control the deployment pipeline so that all of them are in sync, then it's fine.
Yeah, I often like the example I often use is if you're thinking about just even a mobile app, right? Like thinking about, okay, I have this kind of set of functionality. It ranges, say it's big enough of what it does. And then you have some interaction from the mobile app to say your API, some whatever the case may be, like everything that's on that, not everything, a portion of what's on that mobile app can belong, like is a logical boundary with the server side. They're deployed in two different ways. They may live in two different repos. They may not, right? Like the are physically separate, built separately. Maybe they're, like I said, maybe they're from the same repo. It's just kind of this mix and match. I have a diagram that I made that I kind of split things up constantly to see all the kind of variations of what something might look like. I just think it's really hard to either want to go down the road of having to think that way about it, because I think it's just easy to say, okay, I have a repo that is a logical boundary that gets built and is deployed independently.
Yeah.
Never mind the scaling part of it, multiple instances, but it's just kind of that one to one to one. And So I think part of that for me has always been, I think that's been some of the trouble. But I'm curious of, okay, if you just take microservices out of it and you're saying now it's a modular monolith where that thing that was a microservice is now composed of other, and we're deploying that together. I don't know whether I'm hesitant to say people would be in a better place. I mean, in some respects, maybe
Mm-hmm.
because of the troubles of the distributed nature of what it was before. Like I love things like OpenTelemetry. I think they are awesome. I think they also could have been a band-aid for a problem people didn't need to have. You know what I mean? If I have an environment where I've shown examples of like, okay, I have a HTTP call come in, maybe it kicks off something to my database, then maybe I publish an event, and then that event gets picked up, and then I can see like this whole workflow because the asynchronous nature of it. It's awesome. It's great.
It is, yeah.
But if I got service A makes an HTTP call to service B, and service B makes an HTTP call to service C, and then it makes a call somewhere else, and then that's because that's what I'm trying to see because I want to trace the whole thing. That's kind of a problem.
I think some of the intents behind the modular monolith are achieving some of the identification of internal coupling between components, because you have to build the whole thing together anyway, but you need to be able to pry the pieces apart. I just hope that we don't end up seeing the bad parts of most of the monoliths that we had 10, 15 years ago, where yes, all the code was great, but it all talks to one single database, or that you rely off of transactions to do absolutely everything. Because then as soon as you do that, it doesn't matter how modular you've made the rest of your components, you can't tear those apart. And then having something like OpenTelemetry into observability to see the flow of things when you tear those things apart isn't going to help you either, because to be able to tear them apart, you still need to break that internal coupling or the dependence on transactions that you've baked into your modularness.
So what do you think? Where do you think we landed right now? Like, do you think that we're in a better place than when we started microservices? Overall, like where do you kind of feel, like what's your general feeling? Like I'm old man where I'm like, no, we didn't learn anything. And then other times I'm like, well, there are lessons that were, I think, that came through. I guess maybe it's too early to tell. But what's just your general feeling?
Okay, so I'm aging myself here, but SOA was fantastic until we got the the enterprise service bus and the compliance teams, and you had your teams that were dedicated to managing your daily power device, and you couldn't make changes to the message flows. Like SOA, the principles of SOA were great, and I think microservices might have been a too strong of a move in the other direction, because we didn't want the compliance teams. We wanted just to be able to have these small independent things that we could change and deploy, and that might have been going too far. The modular monolith part is, I think, I don't want to say an overcorrection, but there's definitely a shift back to cohesion, more cohesion, which is going to make some things easier. I hope that as an industry we start spending more time thinking about the coupling that we introduce in between the components. I think if you can get that right, a lot of the problems with all of the technology or design type choices that we've been discussing would be lessened. If we had the coupling right with microservices, the coupling and the cohesion, as you said, the balance between the two right with microservices, wouldn't have these horrible screenshots of, it was at Netflix or Uber where they had like hundreds and hundreds and hundreds of microservices deployed. In fact, there's a customer that I've got where they when they deploy an endpoint, it becomes immutable. It's there forever. Like they never decommission, they never change that endpoint. It's out in the world, and that's it. Um, when I first saw that, my reaction was, "Wow, that's really
Yeah,
cool, but why?"
yeah.
um, so I think what I'm hoping is that we're sort of like circling around, getting closer and closer to something that's a bit better. Um,
Yeah, I think that's a good way of putting it. That's kind of what I've been hoping is kind of narrowing in a little bit, and
I hope so.
through kind of the iterations of this, it's been it'll end up in a better place.
Yeah.
Um,
We do seem to come up with the most complicated ways to send little angle brackets down to the browser
I know, right?
to
It's
render
like too much.
JavaScript.
I want to thank William from Particular Software for having this conversation. That was pretty insightful. If you enjoyed this style of video where I have a guest on, have a more of a kind of casual conversation like this, let me know in the comments. And if you want to get in on conversation about software architecture and design, you can join my channel and get access to a private Discord server where you can interact with other software developers about topics like this. Check the link in the description on how to join. If you found this video helpful, please give it a thumbs up. If you have any other thoughts or questions, make sure to leave a comment, and please subscribe for more videos on software architecture and design. Thanks.